In this video, we'll talk about rational and irrational numbers. Rational numbers are all the fractions or all the numbers that can be expressed as fractions. Like, let's say if I have a whole number 5, I can still put it in a fraction as 5 over 1. Or maybe the fraction is already given. So rational numbers are fractions if the whole numbers are on the top and on the bottom, like 4 sevenths and negative 3 eighths. If I have a over b, both a and b have to be whole numbers. That will be rational. Integers are rational. Rational are good. Integers are positive and negative whole numbers. They are rational. Negative 4, 11, negative 107, 24, 0. They're just some examples of positive and negative numbers. If it is just a whole number, that is a rational number. Rational examples can be ending decimals, decimals that stop. They are ending. So examples, 0.35, stop. 5.271, stop. Negative 9.8, stop. Ending decimals are fine. They are rational. What if the decimals don't stop, but they keep going? They are fine. They are rational if they have a pattern. In other words, I can predict what's next. Like 0.33333, so that means it's going to be 333 and again forever. Repeating decimals can be put in a fraction. They are good. They are rational. They are predictable. They're fine. So ongoing repeating decimals means the decimals that have a pattern, like 5.1212. So I can predict that it's going to go again, 1, 2, 1, 2. That prediction or the pattern we can use to place a number in a fraction. Perfect squares are the square roots that have the answer whole number. Like square root of 4, if I simplify, that's 2. 2 times 2 is 4. Square root of 16 is perfectly fine. That's 4. Square root of 121, that would be 11. So perfect squares are essentially whole numbers, and they are in the rational category. So all the fractions with whole numbers are rational. All the whole numbers, positive and negative integers, are rational. Decimals that stop, great. We can put them in the fraction. They're rational. If there is a repetition or a pattern in a decimal, ongoing repeating decimal, great. They're fine. They're rational. They make sense. Perfect squares simplify to whole numbers, so they're rational as well. So those are reasonable numbers. They can be put in a fraction. Well, for everything rational, we have to have something irrational. So what about numbers that are irrational? Well, those are like the crazy numbers, not predictable, ongoing decimals, decimals that do not stop, and there is no repetition. Crazy, irrational. The symbol pi representing 3.14 when we use for circumference and area of a circle, we round it to 3.14. It doesn't stop at 3.14. So the symbol pi is an irrational number because it's an actual decimal that does not have repetition, goes on and on and on forever. So it makes it crazy, irrational. So even on the calculator, we have the symbol pi. And if you click on it, it gives you 3.14 that we round to, but then 1, 5, 9, 2, 6, 5, and 4, and it still doesn't stop because there are many numbers behind that have no repetition and do not stop. So the symbol pi is irrational because it's an actual decimal value that is ongoing in a crazy way with no pattern. Not perfect squares. Those have roots that do not equal a whole number. So for every perfect squares, we had square root of 4, 2, that's rational. Square root of 16, 4, that's rational, whole numbers. But the ones in between, they're not perfect squares. If we do the square root of 2, let's see here. We have a decimal that has no repetition. 41421357 562. That's how, not a repetition. It goes on forever. It doesn't fit in the calculator. So 1 point and a lot of craziness. Irrational. Square root of 8. That is irrational because it's an ongoing, not predictable decimal. Square root of 15, not a perfect square. And again, if we simplify, it's an ongoing, not repeating decimal. So irrational numbers are not predictable. They're decimals that keep going forever and they don't stop and don't have a pattern. So ongoing decimals that are predictable, look at it, they're nice and organized, they are good. But ongoing decimals with no pattern in them, oh, crazy. They are irrational. So we're going to see a few examples. Let's say I have a problem and I need to circle all my irrational numbers. So I look at my irrational numbers and I notice the symbol pi. Okay, that's irrational because it is ongoing, not predictable, 3.14159 and so on. It is not a predictable decimal. Pi is irrational. 4.17, stop. Okay, well, if it stops, that's great. A stopping decimal is in the rational category. X over y, if x and y are whole numbers, that's rational because by definition, rational numbers are fractions or numbers that can be put in a fraction. So if I have a fraction with whole numbers on top and bottom, that would be rational. So in this situation, if x and y are whole numbers, that will be a rational example. We need irrational. Here we go. 0.423635. Go, 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 go. Don't stop. What's next? Don't know. No idea. Irrational. Crazy. Square root of 5. How much is square root of 5? Let's see. Square root of 5 is 2.23606. Oh, that's not any prediction there. Irrational. This is not a perfect square. Here we have 0.33333. I can predict that it's going to be 3333 forever. Prediction or pattern makes it rational. So the irrational numbers are pi because it's ongoing, crazy decimal. 0.436, no pattern going on there. That is ongoing, non-stopping, not predictable decimal, irrational. And not perfect square 5. Square root of 5 is not a whole number. That's irrational. What if I have to circle all the rational numbers? In other words, the ones that make sense. They are fractions with whole numerator denominator. Pi, no. Pi is irrational. Decimal, 8, 9, 2, going on, no pattern. Ongoing decimal that doesn't stop and it doesn't have a pattern is irrational. What do we have to circle? Rational. So nope, not this one. Rational number, 0.89. Stop. Good. Stop is good. This is called ending on terminating decimal. So in my chart, ending decimals are good. They're just fine. They are rational. Square root of 25 is rational because it is a perfect square. 5 times 5 is 25. Square root of 25, if I check, is 5, a whole number. Whole number is an integer. That's rational. So let's look at a few more examples here that I have to identify if the number is rational or irrational and explain. So first example I have point, so it's a decimal number. I have ending decimals that stop. This one does not stop. I have ongoing repeating decimals. This one does not repeat. So for decimals to be rational has to stop or have a pattern. What if that's a no and that's a no? Then it becomes irrational because it's ongoing and it's not predictable. So this one is irrational number. And it is irrational number because it's ongoing, not predictable decimal. Ongoing means keeps going forever. Not predictable means no pattern. Now, square root of 12. Question. What is square root of 12? Square root of 12 is ongoing, not predictable decimal. So this square root of 12 is again irrational. I'm going to say because it is not a perfect square. And if we don't have a perfect square, that is going to be a decimal number that is going forever with no pattern. How about the fraction? Example number 3. Fraction with whole numbers on the top and on the bottom. They're perfectly fine. Fractions with whole number on top and bottom are rational. Because it is a fraction with whole number on, you can say numerator and denominator. On top and bottom. How about negative 45? Negative 45 is perfectly fine number. I can put negative 45 in a fraction just by simply putting it over 1. Negative 45 is a fine number. That is rational. Because it's an integer or a whole number. Let's look at a few other examples. I have negative 1 and then 0.33333, and I can predict that it's going to be 333 again. So ongoing decimals, if they stop, they're good. This one is ongoing with a pattern. They're good. So for decimals, we have in the rational category either stopping or if it's ongoing in the pattern. This one is going in the pattern, so it's a rational number. This is an ongoing, repeating, or predictable decimal. Example number 6, it's a decimal. Does it stop? No. Does it repeat? Is there a pattern involved? No. So it's not rational. Where do I have another decimal? Here. In the irrational category, we have non-predictable or not predictable ongoing decimal. So that is irrational. Why? Because it's not predictable. Ongoing means keeps going forever. Decimal. That's irrational. How about square root of 25? Square root of 25 is a perfect square that equals 5. It equals a whole number. That makes it rational. So all the perfect squares where the root is a whole number means integer, that means rational. Square root of 25 is a perfect square. A fraction with whole number on top and on the bottom is a rational number. In addition to that, if I use division, 45 divided by 6, I have 7.5, a stopping or terminating decimal. So a fraction with whole number on top and on the bottom results to an ending decimal, which is still rational. So rational because it is a fraction with whole numbers on top and bottom. I have a decimal. Does it stop? No. Is it predictable? Yes. Predictable decimals, or the ones that have a pattern, are great. They're rational numbers. Why is that a rational number? Because it's ongoing and it's predictable. It's a repeating decimal. Ongoing means keeps going, but it goes in a pattern. Ongoing repeating decimals are fine. They are rational. And last example, our symbol pi, it is irrational number. because the symbol pi is an ongoing, not predictable, crazy number. So irrational number representing ongoing, not predictable decimal. If I put pi in the calculator, I see a decimal number that is going to keep going forever and ever, and it has no repetition in that decimal part. So the symbol pi, we rounded to 3.14, but that is just an estimate that we use for simpler calculations. It is not stopping, it's ongoing, and it's not a predictable decimal. So the rational numbers, we have fractions with whole numbers on top and bottom. Ending decimals, it means stop. Integers or whole numbers, positives and negatives. If we have a repetition and things are predictable, that's good, rational. Perfect squares are perfect. They have whole numbers in their answers. So they're fine. They're rational. How about the crazy ones? Irrational numbers will be ongoing with no pattern decimals. Not predictable. Symbol pi is an ongoing, not predictable decimal. That makes it irrational. And all the squares that are not perfect, they don't equal a whole number if you were to put it in a calculator. They will be decimals that are ongoing with no pattern. So those are all irrational.